Have you ever wondered how activity on the sun can affect life here on Earth? Solar storms are one of the most fascinating and potentially disruptive phenomena in our solar system. But what exactly is a solar storm? A solar storm occurs when the sun releases bursts of energy and charged particles into space. These storms happen because the sun is not just a giant ball of gas, it's a massive dynamo, constantly churning with magnetic energy. There are three main causes of solar storms: solar flares, intense bursts of radiation from the sun's surface, releasing light, heat, and high-energy particles. Coronal mass ejections, or CMEs. These are enormous bubbles of gas and magnetic fields that erupt from the sun's corona, often following solar flares. High-speed solar wind streams of charged particles flowing from the sun, especially from coronal holes, dark patches on the sun's surface. When these solar activities reach Earth, they interact with our planet's magnetic field, sometimes causing significant disturbances. Solar storms manifest in different ways, each with unique effects. Geomagnetic storms. These disturb Earth's magnetic field and can disrupt navigation systems and power grids. Solar radiation storms. Bursts of charged particles that are dangerous for astronauts and high-altitude flights. Radio blackouts. Intense solar flares that interfere with high-frequency radio communications and GPS signals. The effects of solar storms can be both beautiful and disruptive. Auroras. The interaction of charged particles with Earth's atmosphere creates stunning displays of light, like the northern and southern lights. Technological impacts. These storms can interfere with satellites, GPS, and communication networks. In extreme cases, they can even damage power grids, causing widespread blackouts. Biological effects. While people on Earth are protected by the atmosphere, astronauts and high-altitude flights may face increased radiation exposure. Solar storms are measured using tools like the KP index, which rates storm intensity from 0 to 9. Satellites, such as the Solar and Heliospheric Observatory, or SOHO, monitor solar activity and provide early warnings to help mitigate risks. History has shown us the power of solar storms. The Carrington event of 1859 was the strongest recorded storm, causing telegraph systems to fail and auroras visible even in the tropics. In March 1989, a solar storm caused a massive blackout in Quebec, Canada, showing how modern technology is vulnerable to these cosmic events. Fortunately, steps can be taken to reduce the impact of solar storms. Space weather forecasting agencies like NASA, NOAA, and ESA constantly monitor the sun and provide warnings. Infrastructure resilience power grids and satellites are being upgraded to handle geomagnetic disturbances. Operational adjustments. Flights can be rerouted and sensitive systems can be temporarily shut down during intense storms. Solar storms remind us of the immense power of the sun, a force that brings life but also challenges. By understanding and preparing for these cosmic events, we can protect our technology and continue to marvel at the wonders of our universe. Stay informed, stay prepared, and keep exploring the cosmos.